Hey seniors, today we're going to continue with systems of equations that we started at the end of break. Today's going to be all about reading word problems and writing equations based on that. So let's go ahead and jump in. On your notes page, go ahead and draw your line. Go ahead and write solutions from words in the top left-hand corner. Don't write this yet. I'm going to tell you what to write. Let's review what systems of equations are. Systems of equations are two separate equations representing two different straight lines. You definitely do not have to write that because you should remember that from your Quizlet vocab. Today, when we're reading descriptions, we always want to look for our starting point. And again, our starting point will always be your y-intercept in the equation y equals mx plus b. So again, when we're writing these equations, we want to have a y equaling some number x plus the y-intercept. So that's just like an example. Let's go ahead and write, always look for a starting point, which will be your y-intercept. Always look for your starting point. This will make more sense when we get into it. Your slope will represent the value that increases or decreases. Definitely write that in your notes page. Let's go ahead and jump into an example. All right, you definitely do not have to write this. I'm just going to read it to you. Marisol and Lupe each opened a savings account on the same day. Marisol started by putting $20 in her account, and she will deposit an additional, I'm going to underline additional, $1 each week. Lupe made an initial deposit of $5, and she will add, I'm going to also underline add, $2 more each week. Eventually, Marisol and Lupe will each have the same amount saved. Write a systems of equations to determine how many weeks that will take. All right, again, I want to write these equations in the form y equals mx plus b, where m is my slope and b is my y-intercept. So I need to find starting points for this data. Well, I can look at my example here, and it says Marisol started by putting $20 in her account. Since I know that my systems are always equal to y, I'm going to go ahead and write that part. But since it says started by putting $20 in her account, that's going to be my starting point. So that's going to be my y-intercept. And it says she will deposit an additional $1 each week. If it's an additional, I know that I have an addition problem. And if it's $1 each week, 1 is going to be accompanied by a variable since I don't know how many weeks it's going to take. If it says Lupe made an initial deposit of $5, that's also going to be my starting point for the y-intercept. If it says she will add $2 more each week, I still don't know how many weeks it's going to take in order to determine them having the same amount. So I'm going to go ahead and accompany 2 with an x. Now, we need to talk about what these numbers mean in the context of a problem. So I have my two equations, y equals 1x plus 20 and y equals 2x plus 5. But what does x and y represent? Let's talk about that. If I'm trying to figure out how many weeks it will take for them to have the same amount saved, y is going to be how much money they have. Amount of money. And x is going to be how many weeks they deposited that amount every week. And I know this because every week that they deposit money, my value is increasing, which makes sense because my slope increases on a graph. So we always want to think about what that means in the context of the problem. Again, today we are not solving these equations, we are just writing them from words. Let's do another example. All right, again, don't write this, I'll tell you what to write. Brendan wrote a business plan for an entrepreneurship class, and now he has to make bound copies. Brendan could use a printer who charges a setup fee, underline setup fee, of $39 and $6 for every copy printed. Another possibility is to go to an office supply store where he could pay an upfront fee, which means a one-time fee, of $30 and $7 per copy. I'm going to underline all of that. There's a certain number of copies that makes the two options equivalent in terms of cost. And remember, equivalent, I'm going to put a box around that. Equivalent just means equal. Write a systems of equations to determine how much the copies will cost. All right. So again, we want to write it in the form y equals mx plus b. So I'm going to go ahead and write my y's. I'm looking for my starting point. Well, if I go back to my example, it says a setup fee of $39 and $6 for every copy printed. So since I don't know how many copies they're going to print, I can go ahead and accompany 6 with a C for copies. That'll be my first equation. Another possibility is to go to an office supply store where he could pay an upfront fee of $30 and $7 per copy. So again, I'm looking for my starting point for my second equation. If it's an upfront fee of $30, since that's a one-time thing, that could be my starting point. And $7 per copy. And again, I'm going to accompany 7 with a C because since it says per copy, I don't know how many copies it actually made, so I know that that value is going to increase over time. So now that I have my solutions, I need to talk again about what these mean. So we're looking for, we're trying to figure out how much the copies will cost. How much the copies will cost. So Y, in this case, is going to represent the amount paid. The amount paid for copies. Because again, we're always talking about how much it costs. C, on the other hand, is going to represent the number of copies made. And I know that because if it's $7 for one copy, and I were to substitute 1 for C, it would just be 7 times 1, which would give me 37 if I had 7 and 37 together. So then that would be $37 collectively. So again, always look for your starting point. Look at the value that's going to increase or decrease for your slope. Make sure you underline key terms. That will help you figure out exactly what the problem is asking you. I think this is going to make more sense just with practice. So let's go ahead and jump into that.